And part of the thing about stoichiometry is if you struggle with writing balanced equations, oh, it makes this hard. On the other hand, the good part about stoichiometry is if you struggle with balanced equations, we get to practice it some more right now. So we can actually figure out how to do this, hopefully. Question number 1 says, when aluminum is heated in oxygen, aluminum oxide is formed. How many moles of oxide can be obtained from 7 moles of metal? Whew. When we read a story problem or a multiple sentence question, let's take this bit by bit. Let's start with sentence number 1. When aluminum is heated in oxygen, aluminum oxide is formed. We should be able to write a balanced equation for that, ladies and gentlemen. When aluminum is heated in oxygen, those are our 2 reactants. Aluminum oxide is formed. That's our product. Why don't you take a few seconds here to see if you can write that balanced equation. Because you can't do stoichiometry without a balanced equation. So that's our starting point. Somebody, anybody, what's the formula for aluminum? Shout it out. Yeah, it wasn't meant to be tricky. By the way, it's a solid. We can look at the periodic table. It's black in the periodic table as a lone element. That means solid. Oxygen. O2 is a diatomic. What phase would that be? Gas. The only formula that required a little bit of, let's remember chemistry then, was the aluminum oxide. Charges on an ionic compound, you either cross and drop, however do you make that correct. The formula is not AlO2 though. What's the formula for aluminum oxide? Addie? Al2O3. Now, you might not know the phase would be a solid for that one, so I'll just let you know that that one's a solid. Hey, by the way, what type of reaction is this? Over 5 reaction types. Synthesis. You make one product, it's a synthesis reaction. Part of that quiz that you're going to see at the end of next week, I'm just going to give you an equation. You have to identify what type of reaction it is. So that's something that is very skills-based. We're not done with this, though. It's not balanced. What should I put in front of the Al? At first, I'd put a 2, but then my oxygens would have to be rebalanced, so I'd have to do a little bit more, or some would say 4. Eventually, I'm going to have to put a 4 in front of it to make it work. 3 in front of here, and what this balanced equation says. The reactants are our ingredients, just like our cookies before, ingredients to make cookies. For every 4 aluminums, 3 oxygens will combine with that to make 2 aluminum oxides. Oh, but what if I wanted to make 4 aluminum oxides instead? How many aluminums would we need to do that? 8. If I want to make twice as much, I need twice as much. How much oxygen would I need? 6. Oh, but maybe I don't want quite that much aluminum oxide. What if I only want 1 aluminum oxide? How many aluminums would I need? 2. How many oxygens would I need? Anyone? 1.5, 1.5. Twice as much, 2 to 4, twice as much, 3 to 6, twice as much, 4 to 8. Half as much, 2 to 1. Half as much, 4 to 2. Half as much, 3 to 1.5. Now, normally we wouldn't put 1.5 as a coefficient because it's not a whole number. What we just did in our head is the first step of stoichiometry. So although stoichiometry sometimes can get scary, because there is more to add to this next week, really, I'm trying to show you a method to do what you did in your head on paper. So, question number 1. Let's go back and erase this part here. The second sentence says, how many moles of oxide, so that's the aluminum oxide, is formed from 7 moles of the metal? When you're doing any type of problem where it gives you a value in the question, write down that part. 7 moles of Al, that's our metal. Stoichiometry is doing conversions. A chemist's best friend, converting. When you convert from one unit to another, whatever you want to solve for is in the top of the conversion, whatever you had was on the bottom. Now this is different than converting from centimeters to meters, or kilojoules to joules, or grams to moles even. This is converting from one element, aluminum, to a different thing. In this case, it wants us to solve for aluminum oxide, Al2O3. And Al will be on the bottom. A balanced equation allows us to convert from one thing in a reaction to another thing in a reaction. So if I know how much I want to produce, I can figure out how much I need to start with. If I know how much I started with, I can figure out how much I can produce, or any combination. In this conversion, however, we need to include the 2:4 ratio from the balanced equation. That's where I get that 2 and 4 from, is from my balanced equation. How any type of conversion works is if I have aluminum right here on the top, it cancels out with aluminum on the bottom, which means algebraically 7 times 2 divided by 4 will give me my number answer, and now my unit will be moles of Al2O3. 7 times 2 divided by 4? 3.5. Our answer would be 3.5 moles of Al2O3. Now, you have to include the units on this. And not only moles, but of what? Because I could have asked you a question like, 7 moles of aluminum requires how much oxygen to react with it? The nice thing about stoichiometry is I can solve for anything in this equation. And because I can convert from one compound or element to another, I have to include what I'd call a complete unit for my final answer. So the questions on this first one. Let's look at number 2. Number 2 says when steam, hot water, is passed over iron, hydrogen gas and iron 3 oxide are formed. Let's just stop right there. Let's not even read the second sentence. The first sentence tells us the reaction. When hot water reacts with iron, is passed over iron, hydrogen gas and iron 3 oxide are formed. Why don't you take a minute to write down the balanced equation for question number 2. To help us time-wise, 3H2O, which if it says steam is a gas, plus 2Fe, iron's a solid. Hydrogen gas is H2. And I'm running out of room, so I'm going to put my Fe2O3 down here, which that one you probably wouldn't know is a solid. Fe2O3 is the formula for rust. Every Stoic problem starts with a balanced equation. Step 2, let's read the second sentence. How many moles of steam would be needed to completely react with 3 moles of iron? I will immediately write down what is given to me in the question, 3 moles of iron. Just like when you did normal mole conversions, you wrote down what was given to you so then you can figure out how to do your next steps for conversions. Then I look back at the question. How many moles of steam is what it's asking for? Steam is the H2O. So that goes on the top of my conversion. The iron, what I was given, has to go on the bottom in order for things to cancel out, top and bottom. And there's a reason why we started chemistry with metric conversions. We use the metric system, but we use conversions. That understanding of canceling out units, that comes into play with stoichiometry. Then looking, it's a 3-to-2 ratio. Three times 3 divided by 2? 4.5. Now granted, right now the sig digs on these problems are supposed to be 1 digit, but when we start introducing this for real next time, past the introduction state like this, we'll have numbers that work better for sig digs. I'd like to try to do one more to wrap up class. Okay. Number 3, how many moles of ammonium hydroxide is needed to react completely with 8 moles of copper 2 nitrate in a double displacement reaction? Oh, that question's getting good. I don't have to tell you the products anymore because you should be able to figure it out. All right, now let's get some real good stuff here. How many moles of ammonium hydroxide? Well, let's figure out the formula of ammonium hydroxide. NH4OH. Reacts completely with copper 2 nitrate. What's the formula for copper 2 nitrate? CuNO32. But the question doesn't tell us the products, Mr. Ratzenberg. But it's a double displacement reaction, Jacob. See, when people watch the video now, they're going to think that was your voice that was kind of wimpily saying that. It was. Let's figure out the products of this. Let's make the switch. Double displacement switch. Take a minute. Try to figure out the products of this reaction. You know, it'd be really good if you're figuring out the formulas of these, you also figure out the phase notations of them. Shouldn't we do that with double displacement reactions? Again, if you figure out the formulas, then figure out the phases. You guys are finally getting to the point where you know enough chemistry where I can start asking you some interesting questions. Oh, and it's going to get better too. A week from now, you're going to look back and think, man, I wish we could go back to last week and what we were doing. If you get phase notations, you might want to balance the equation as a whole as well. I'm actually going to write the products right below because I ran out of room on the right-hand side because in all my excitement, I wrote really big. NH4NO3 is one of the products, right? That's aqueous, if you looked on your table solubility. Number one issue that I'm seeing, ladies and gentlemen, is people are writing this as the formula for copper 2 hydroxide. Yeah, take a good look at yourself if you're one of the people that did this. Shame on you. Parentheses with the 2 on the outside. This is our solid. Equation's not balanced, though. 2 nitrates in the reactant, 2 nitrates here. Equation's balanced. You can't do Stoich without a balanced equation. If I look back at the question, it gives me 8 moles of copper 2 nitrate to begin with. wants me to solve for how many moles of ammonium hydroxide. There's 2 of the NH4OH for every 1 of the CuNO3 2. Students are always asking me, what can I do for the least amount of work to still get credit for it? I want a conversion that not only shows the 2-to-1 ratio, but what's in it as well, NH4OH. I hope we don't need a calculator for this one. And yet I'm not hearing an answer. 16. And remember, unit moles, NH4OH. What if I were, instead of asking to solve for the NH4OH, what if I asked you how much precipitate was made? The copper 2 hydroxide. If I started with 8 moles of copper nitrate, how many moles of copper 2 hydroxide would be made? So again, if we started with 8 moles of copper nitrate, and I asked for how much of the copper hydroxide was made, what's the ratio between copper nitrate and copper hydroxide? It's 1-to-1. We'd have 1/1, which means it would just be 8 moles of it. You can get that with stoichiometry sometimes as well.